Now, another aspect that we want to look at is the periodic nature of these functions. And they're periodic because they repeat. They have certain periods that they repeat. If you have a function where you have s plus p, that's equal to f of s. And what this means is that you have function values, their outputs are going to be the same for here and for here, as long as it's a difference of one period. Let's take a look at what we have in our GeoGebra example here. And let's say I look at this value right here. This is about at 1 point whatever. And then I'm going to go all the way over to here. I'm going to find a similar value at almost 7.4. And what happens is that the difference is 2 pi, and it's cyclic, and it goes through this whole entire sine wave in the course of one period. And that period for this function happens to be 2 pi, which makes sense because when we were talking about circles, that function would go all the way around in 2 pi radians. If I zoom out, we can see that this periodic function just repeats. I'll get rid of the cosine function right now. So we're just looking at sine, and it repeats. It goes over and over and over and over again, and it repeats in this pattern. Now, the reason why this is really important is because this is how tides work. They ebb and flow with the phases of the moon. Radio frequencies, megahertz, gigahertz, anything that has hertz as cycles per second, that's also a periodic function. So when you listen to the radio or the sound of my voice even, those are all parts of periodic functions. The pitch of my voice depends upon how many cycles it happens per second this happens. So in the next video, we're actually going to look at the properties that these sine and these cosine waves have. We're going to look at their equations, and we're going to look at their attributes, and we're going to look at how that actually changes the function.